Hey there, hope you're doing well. Michael here. All right, induction is valid and certain. David Hume was wrong. There is no problem of induction in the real world. Induction is certain and valid and true when done properly, just like anything else. If you use a hammer wrong, then yeah, the nail won't go in correctly or in at all. The hammering does not work. If you try to build a house wrong and do a lot of errant things, of course you will not build a house and it will not stand. That is not a problem with building or houses, that is a problem of how you did things. Induction done properly is valid and true, just like anything else, just like induction or classification or definition or working a math problem. All projectiles move in semi-parabolic orbits is true and has been true since Galileo's time and will continue to be true. Different places, different times, in the context in which it was identified, obviously, because the identity of the things matters. It's not some out of context statement, some floating abstraction that's in the mind only. It is an identification of things in the world. These things do this in this context, period, end of story, is a contextual absolute with these things and these cause-effect relationships that come about because of their identity. There is semi-parabolic orbits. All lightning is electricity. Man is mortal. Deduction is parasitic on induction. Planets orbit the sun in elliptical orbits with the sun at one focus. Water runs downhill. All functions continuous on a closed interval and differentiable on an open interval have at least one point in the interval where the direction or slope is the same as the average direction or slope of the function on the interval. We do this a lot. We make statements about all friends, whatever. All waiters or waitresses, whatever. All butter, all stoves, all cars, all window AC units, all glasses, all coffee, all cats, all dogs, all mammals, all computers, all electric outlets. Everyone who works there, all sports, all students, all teachers. Generalizations are part of our everyday life, our mental function. They are very important. So to say that these are only probable, induction is not valid, throws into disarray and confusion our whole world and mental functioning and lives. If it were true, it's much nonsense. Look at reality with the things I said. These are valid. We use them. When we form them right, they are fine. If you jump to conclusions or say in irrational hate and anger, everyone who works there, I hate them. Yeah, it's wrong. It's invalid. Or they're bad. Of course, you can say you hate everyone there, and that's valid if you hate them. But if you say they're horrible and bad workers, you can't do anything just because you hate them, well, that's not a valid induction. That's just an irrational, hate-filled statement. So we use this stuff in everyday life. It's valid. We see that. There are contextual absolutes, as we said with the projectiles, or water runs downhill. Water always runs downhill. That's in a certain context. Of course, if it's raining and you're driving in a car 60 miles an hour or so, the rain strikes the windshield and it will not go down, it will go up, blown by the wind. So there's a different context. It is not that there's a failure of water to run downhill, as that on the part of some people, there's a failure to identify the causal context for it. What things are identified in that statement, and what is the causal context? adding wind changes the context. Of course, it's a different statement. That's an entirely different thing than people are talking about when they say water runs downhill always. Same with these other things. So, I think it's clear when you look at reality, when you think about how things really work, you don't get lost in the mind or get confused by some statement you haven't thought of before. These are contextual absolutes. The thing with certain other things, there's going to be these causal relationships that will happen. Place doesn't matter, time doesn't matter. What matters is the entities, the things. The idea that something should apply divorced from thing and fact and causality is irrational. That's a severing of thought from reality. It's severing an effect from the cause. You can't have knowledge apart from reality and a mental process. It's a consequence, not a thing that stands alone. There's knowledge in the sense of the process and knowledge in the sense of the product. The product takes the process about the world. And knowledge is an awareness of reality in the first place. All right. And then we see there's necessity in experience. Things have to do what they do. There is no option. A thing is what it is. A is A. A thing is a thing. And things interact in a certain way. We see that in experience. That's why we can act on it necessarily, think about it. That's why other animals can do that. Necessity is found in the world. That's where it comes from, first and foremost. It's inexperience. We identify it in experience because it is in reality. It has necessity being in the world has epistemic and metaphysical priority over anyone's imaginings and ramblings. I don't care what David Hume wants to imagine, the kind of ramblings he wants, what he wants to try to put over on people. That doesn't have priority. His imaginings do not have priority over the facts. What is in experience and in reality has epistemic and metaphysical priority over anything David Hume wants to say. There's, in experience, we have a richness of things. There's things, their actions, their attributes, their relationships. Like with projectile motion, looking at the things that we classify that way, the things that engage in, so to speak, projectile motion, the projectiles and how they move in context of the world in a certain limited context. We look at them, and that's where we're going to figure things out about them, not in the mind. We don't figure out about air resistance from some prior deduction. We got to know about the world and about resistance in the first place. We don't get the parabolic motion out of nowhere in our heads in the first place. We get it by studying reality and developing ideas by looking at shape and things, and the shape of the motion is there in the world, and it is for us to discover, not to impose on reality. What is his epistemic and metaphysical priority? All right. So we just got to make sure we're getting a valid deduction, and there's some causality involved. We're looking at the nature of the thing and the nature of the things it interacts with. If you say, all members of this race are horrible, well, that's invalid. People, as Martin Luther King Jr. identified, have character. They have free will. They have volition. They are self-sovereign rational animals. They are determined by their choices, not by the color of their skin, as he pointed out. The color of their skin doesn't determine their cognitive or moral character or content. So that would be an invalid induction. Or all redheads are hot-tempered. Again, that's an invalid induction. Just like people make mistakes in reasoning also. It's not just in induction. People say, oh, look, there's this induction you got wrong. There's this one. Oh, induction's invalid. Well, yeah. Well, so, same thing with deduction, with reasoning in general. If you're going to say that, then all reasoning is only probable and invalid. All deduction is only probable and invalid because people make mistakes on it a lot or don't engage in it. There are rules of deduction, but people don't even know them all. And so we'll misapply a generalization to a particular thing and get it wrong. You're a witch, you're a criminal, so on and so forth. You're a bad person. No. Or you're a good person. Or they think someone's a friend who's not. They're misapplying a generalization to a particular person. That's failures of deduction. But deduction is not valid. It's how the person did it that was invalid. So that's what we got to do. Not get lost in what Hume said. There is no problem of induction. As E. Bright Wilson, a professor of chemistry at Harvard, said, I forget when he was alive. I'll have to look that up. But I'll put this quote in the description field. I'll put in the description field as much as will fit. It's limited. There's only a certain amount of characters. But I'll see what I can do. But he talked about practical scientists, but I think he means scientists in general and adults in general. I think we can apply what he's saying here to adults. I'll quote what he says, but when he says practical scientists, I think this applies to adults, or people who think about epistemology and stuff and about inductions. And he says, listen to philosophers, but this is what he's talking about is only some modern philosophers, not all philosophers. You listen to J.J. Gibson, qua philosopher. J.J. Gibson, the psychologist who developed the theory of the ecological approach to visual perception. This doesn't apply to him, qua philosopher. Or you listen to Dr. James Lennox, a now retired but world-leading expert on Aristotle's biology and on the development, some aspects of the development of science. He would not say this. So this doesn't apply to all philosophers, but most modern philosophers. Okay, so with that qualification, E. Bright Wilson said, quote, practical scientists who rashly allow themselves to listen to philosophers are likely to go away in a discouraged frame of mind, convinced that there is no logical foundation for the things they do, that all their alleged scientific laws are without justification, and that they are living in a world of naive illusion. Of course, once they get out into the sunlight again, they know that this is not so, that scientific principles do work, bridges stay up, eclipses occur on schedule, and atomic bombs go off. Nevertheless, it is very unsatisfactory that no generally acceptable theory of scientific inference has yet been put forward. Mistakes are often made which would presumably not have been made if a consistent and satisfactory basic philosophy had been followed. Unquote. Agreed. Or Einstein. Here's a quote from him. Now, I don't recommend studying what he believed in philosophy because he was wrong. The Aristotelian influences, the Galilean, the Newtonian influences on him were good, but he had some very bad influences too. He did some great work, but I think he was also flawed in some areas, just like Kepler. Kepler did some very good work, but he also did some weird, strange stuff. And Kepler, of course, for those who know, For those who don't know, he was the one who discovered that the planets go in elliptic orbits. He discovered Kepler's laws. Now, Robert A. Thornton, a physics professor at the University of Puerto Rico, had written to Einstein about persuading colleagues about the importance of philosophy of science to scientists and to science. And in this letter from 7 December 1944, back to Thornton, responding to Thornton, Einstein said, quote, "I fully agree with you about the significance and educational value of methodology, as well as history and philosophy of science. So many people today, and even professional scientists, seem to me like someone who has seen thousands of trees but has never seen a forest. A knowledge of the historic and philosophical background gives that kind of independence from prejudices of his generation, from which most scientists are suffering. This independence created by philosophical insight is, in my opinion, the mark of distinction between a mere artisan or specialist and a real seeker after truth." Unquote. I agree. So, when we look at where this idea that induction is uncertain and probable and this other nonsense comes from, we see it's invalid. That's one thing we should do. Instead of thinking, oh, people say it and that's the way it is. No, why? Be like a scientist or detective. Just as in the particular science one does, if one's a good scientist, one never just takes someone's word for it. One investigates it on their own and understands it and sees the cause and where it comes from. So also with this, it doesn't come out of nowhere. Where does this come from? Why? What's the cause? And, it's not just them. It's not just me. I am consistent with the beliefs and practice of Galileo and Isaac Newton. And me, I'll take what Isaac Newton thought and did in this respect way before I'll ever take Hume serious. Isaac Newton was a serious scientist. Look at how he thought and what he did versus what Hume did. Okay, Hume, nothing. All he did was say, oh, we can't be certain. All our generalizations are merely probable and cannot be counted on because the future could be different and we don't know about the uniformity of nature. Nonsense. So he just throws people into confusion. So no wonder if you can't trust your thinking, the conceptual method is what he's really attacking. If you can't generalize, use your concepts of dog, cat, waitress in general on things to think. That's what's going on. That's the fundamental, that's the implications here. If you can't generalize, then that means you can't get a general thing, a concept of something, dog, cat, waitress, human, planet. You cannot think about that in general terms beyond the particular things that you've seen. It's only habit or custom. It's not real, scientific, legitimate, logical stuff he'd claim, which is a bunch of nonsense. Look at what Newton did. The things Newton did were true at his time and are true at this time, and it's universally true in a timeless fashion, as we said, in a contextual absolute. Hume is what he said is nonsensical. So, for example, with Galileo and Newton, here is a quote of Galileo. It's from the second letter of Galileo Galilei to Mark Welser regarding sunspots. This is from page 118 of Discoveries and Opinions of Galileo, translated by Stillman Drake. At least my edition of it. Galileo said, quote, "I should even think that in making the celestial material alterable, I contradict the doctrine of Aristotle much less than do those people who still want to keep the sky inalterable. For I am sure that he never took its inalterability to be as certain as the fact that all human reasoning must be placed second to direct experience, unquote. There's a generalization right there. All human reasoning must be placed second to direct experience, unquote. And here he's talking about the fact that given what they knew at the time, like everyone else, it's not just Aristotle. People want to dog on Aristotle, which is ridiculous because pretty much everyone else at the time thought the same thing. And because of his method, if Aristotle lived nowadays, he would say, oh, the earth goes around the sun. Whereas some people back then would say, the evidence of the senses is invalid. You think the earth goes around the sun, but that's just your inferior reasoning, going by experience. I know better, and I know the earth goes around the sun because it's pure reasoning. I mean, the sun goes around the earth, they would say, because that's the way it has to be. You got to look at what someone believed and why and how and what their method was and what their epistemology was if you're going to understand them correctly and not be full of lies and hate. So, Aristotle, like many other people at the time, thought because of what they knew, the knowledge they had available, and questions that were not answered, they thought the sun went around the earth. Okay? Because you don't feel the earth moving. If it's spinning around so fast to make night and day, and if it's shooting around the sun, like shooting around the sun at 2,000 miles an hour or something and spinning it like, 400 or 600 or something, I forget the exact figures, but easy enough to look up or calculate. If that's happening, then why don't we fly off? You got to explain that. You can't just say, oh, everyone knows the earth goes around the sun. No, you don't. That is not knowledge. That's just a statement of what people say, not what people know. That shows a lack of understanding of what knowledge really is. So, people thought, and it was in Aristotle, that the sun goes around the earth. And so these scholastics who would study Aristotle would say, that's the way it is. They did not think for themselves. They did not do like like Galileo, and say, oh, all human reasoning must be placed second to direct experience. So I need to go to experience first, not someone else's words, not my own thoughts. Experience, evidence of the senses first, and reason from there. That's what Galileo did. But these people didn't. So he knew Aristotle better than they did. But they would say, Galileo, you're wrong. In Aristotle right here it says the sun goes around the earth. Therefore, that's the way the reality is. And he's saying, no, the earth goes around the sun. And he knew things about, because of his use of the telescope, about how there's mountains and valleys on the moon. It's not smooth. There were planets around, rings around Neptune, planets around Uranus. Venus had phases. I think those are some of the things he knew. He knew about sunspots on the sun, as the title of this letter identified. He studied sunspots and how they moved and showed that things in the heavens weren't inalterable. There's change out there. Because people used to think, because of what they knew, they never saw any change. No growth and decay, no change in orbit, no coming into being or leaving. The same stars were there in all the records in the Egyptians and Mesopotamians before the Greeks. Same thing, same place. Maybe some minor regular circular variation, but nothing different. Same thing all the time. No change. So they didn't have evidence for the things change, so you can't claim it. You got to have evidence and facts in perception to make some valid hypothesis. If it's not evidenced, it's not a valid hypothesis. It's just nonsensical imagination that needs to be dismissed. So, as Galileo said, all human reasoning must be placed second to direct experience. Direct experience is the standard. Or as St. Thomas Aquinas said, nothing in the intellect was not first in the senses. Nothing true. Nothing, no real awareness of reality. Okay, that's Galileo. And shows you that's consistent with thinking about valid inductions, because that's what he did. The law of the pendulum, the law of free fall, the law of the inclined plane. He studied these things, studied sunspots. He made generalizations about things. He conceptualized, he made generalizations. All free fall occurs in a way where the distance fallen is proportional to the square of the time. Things like that. Now Newton, he knew causality and induction were valid. As we all know, the way we use it in the world. So, Newton's rules of reasoning in science. These were in the Principia. Okay. I'll read them all for completeness. Rule 4 is kind of what's relevant here, but I'll go ahead and read them all. There's only 4. They're short. Rule 1. We are to admit no more causes of natural things than such are both true and sufficient to explain their appearances. Rule 2. Therefore, to the same natural effects, we must, as far as possible, assign the same causes. Rule 3. The qualities of bodies, which admit neither intensification nor remission of degrees, and which are found to belong to all bodies within the reach of our experiments, are to be esteemed the universal qualities of all bodies whatsoever. Unquote. Okay, and so far, the first two, easy to listen to, but the third one, maybe a little bit hard to grasp while you're listening, but I'll put them in the description field so you can read along. You can look there, description field of the episode. And then I'll put a link, and you can look them up in the Principia. Anyway, I got a link to these if the link still works, but maybe I'll see if I can get a link to the Principia too, where they are. Okay, rule 4. Quote rule 4. In experimental philosophy, unquote. Wait, and that means physics. Philosophy at the time meant like experimental philosophy. He was talking about physical philosophy, physics. Back then, philosophy was the general term used. And then, of course, things developed. So philosophy came to be the specialized field you think of nowadays, and physics was a different field. But philosophy just meant all knowledge at the time. So, quote 4, quote, rule 4, in experimental philosophy, we are to look upon propositions inferred by general induction from phenomena as accurately or very nearly true, notwithstanding any contrary hypothesis that may be imagined, till such time as other phenomena occur by which they may either be made more accurate or liable to exceptions, unquote. Okay, so I'll read that without the notwithstanding clause. So, quote, in experimental philosophy, we are to look upon propositions inferred by general induction from phenomena as accurately true or very nearly true till such time as other phenomena occur by which they may either be made more accurate or liable to exceptions, unquote. And here, at least the way I read this, exceptions doesn't mean, oh, Hume was right, they're only probable. No, it's a bunch of nonsense. The induction is true. The exceptions mean, oh, there's some context or cause we didn't consider, and we can refine this to have other inductions. The induction we had was true. Then maybe we need to have a qualification for it that we didn't know about, or we got a broader induction or a narrower induction. We got subclasses of things we can look at. So, for example, all dogs bark. And then you'll learn, oh, this one doesn't. Well, why? Oh, because this voice box is injured. Ah, okay, yeah, all dogs bark under like what we might call normal or typical circumstances, but they can be hurt. Ah, yeah, of course, like other animals and things. Things can be hurt, injured, and that can affect what the thing can do. But without that, it would still have the potential to bark. And all dogs under these conditions bark. It's still a contextual absolute. It is correct and certain. The injured dog does not contradict it. It just adds to what you knew. Because that's what you were assuming. And we know when we're thinking about reality and learning, we don't know everything. We don't impose on reality. We bow down before reality. We learn something, and then we learn more. And then we add that to the whole of sum of our knowledge. We see, it's not that we're wrong, it's that there's this cause we did not consider or know about. Just like anything else. And that's what a good reasoner does. They are identifying things in reality and knowing there's always more for them to know and learn. They are correct absolutely within the context of needing to learn more and all that and knowing that they will, and so on and so forth. It's not arrogant. It's putting reality first, the whole richness of it, knowing there's so much more to learn. It's not being an arrogant, irrational rationalist and want to impose on reality. So that's the kind of thing with exceptions. Or you learn that, okay, so Newton developed his laws in physics in context of things on an everyday scale and things that were maybe no more than 7/10 the speed of light. He did not know about atoms. So the amazing thing is that we can extend these generalizations beyond the context he had to things at the atomic level. And then we see, when we bring in these other factors or causes or these other things with their identity and characteristics and attributes and actions, when we bring this into play, then we will modify this generalization. But that's because there's more things than the generalization in which it was made. Or there's like a quote-unquote exception when you go closer to the speed of light, but that was out of the context of the context he had to develop his generalizations. So when we are going to go to a broader context with other causes, other factors, other things, then we adjust accordingly. And that'd be the exception thing. But within, and that'd be other phenomena occur. So with the phenomena he had in that context, it's a contextual absolute, as we've seen. Reality shows that. Time doesn't matter, place doesn't matter. Only the identity of things and their cause-effect relationships matters. That's timeless. So, we got the backing of some very intelligent, wise, rational people who have been very successful in science and thought and reasoning. Newton engaged in a grand scale induction, way beyond anything Hume has ever done. Newton, for one thing, engaged in a grand unification of the terrestrial and celestial. They had been things in astronomy and space and things on Earth. They had been thought to be different. Things on Earth changed. They'd follow a zigzag motion, maybe some straight line stuff. Things in the heavens, people thought, engaged in curved circular motion, were timeless, never changed. But Newton fully developed the unification of the two, the physics that they were the same. There was developments with Kepler and Galileo and other people, but Newton finally made a grand unification that the others hadn't before. Galileo studied some terrestrial, Kepler, Copernicus, some others studied celestial, and then Newton showed, the fall of an apple is identical to the fall of the moon, just on a different scale. The Earth is pulling them both. And you can argue, okay, it's a force, it's like curvature of space or curvature of stuff in space or whatever. Okay, we're not going to go into that right now. The point is that he showed that they're similar. There's the same physics in both places. You don't need a different physics for Earth and one physics for Earth and another physics for stuff in space. He engaged in that grand unification, and he studied light and other stuff. So those generalizations are valid. There's one right there. All things on Earth and in the heavens follow the same laws of physics. That is a valid generalization. No probability about it. No, oh, well, it's only in time or only these things, or I don't know about the uniformity, 100% certainty there. So there's no doubt about the future versus the past. Is there uniformity? No. We know, and Newton knew, that these generalizations are valid. Period. End of story. Hume is wrong. So there's some looking at reality first. Okay. I want to be clear that Hume is wrong, and we know that. Galileo knew that. Newton knew that. E. Bright Wilson knows that. Einstein knew it to some extent, but could have known better. I wish he had a better overall philosophy of science. But I heard he was a decent guy too. Super nice, friendly, helpful. That's super cool. So we've got that established. Okay, so now I think we can properly more think about Hume. So here is a quote from Hume and some of his argument. Okay, this is from an abstract of a book lately published entitled A Treatise of Human Nature, and etc., wherein the chief argument of that book is farther explained, illustrated, and explained, unquote. That's the title. In short, just the abstract. And I'll either put a link to this or put it in the description field, depending on how much room there is, how many characters I could put in there. And then you could read along, look at it yourself, validate, verify, think about it. And it was published anonymously, but many people think it was written by Hume. Some people think maybe it was written by his friend Adam Smith. Adam Smith, the economist. I think that's the Adam Smith it was. A Wealth of Nations and all that. But, so here is what Hume wants us to think about induction. Contra Newton. Contra Galileo. Contra what we actually do and believe in our everyday lives. Contra E. Bright Wilson. Contra, I think, the facts of reality. Hume says, okay, 1, 2, 3, 4, 5 paragraphs. So, let's listen. Let's let Hume speak. Quote. Okay, well, he's starting, building off on something else. I think this is starting from paragraph 11. And he says, this is the case, referring to something else. But that's kind of not so much the important part. There's some particular things he's saying here that I want to bring out. Quote, this is the case when both the cause and effect are present to the senses. Let us now see upon what our inference is founded when we conclude from the one that the other has existed or will exist. Suppose I see a ball moving in a straight line towards another. I immediately conclude that they will shock and that the second will be in motion. This is the inference from cause to effect. And of this nature, we all and of this nature are all our reasonings in the conduct of life. On this is founded all our belief in history, and from hence is derived all philosophy, excepting only geometry and arithmetic. If we can explain the inference from the shock of two balls, we shall be able to account for this operation of the mind in all instances, unquote. And he's talking about getting the idea of cause and effect and generalizing. Quote, were a man such as Adam, created in the full vigor of understanding, without experience, he would never be able to infer motion in the second ball from the motion and impulse of the first. It is not anything that reason sees in the cause, which makes us infer the effect. Such an inference, were it possible, would amount to a demonstration, as being founded merely on the comparison of ideas. But no inference from cause to effect amounts to a demonstration, of which there is this evident proof. The mind can always conceive any effect to follow from any cause, and indeed any event to follow upon another. Whatever we conceive is possible, at least in a metaphysical sense. But wherever a demonstration takes place, the contrary is impossible and implies a contradiction. There is no demonstration, therefore, for any conjunction of cause and effect. This is a principle which is generally allowed by philosophers. Quote, it would have been necessary, therefore, for Adam, if he was not inspired, to have had experience of the effect, which followed upon the impulse of these two balls. He must have seen, in several instances, that when the one ball struck upon the other, the second always acquired motion. If he had seen a sufficient number of instances of this kind, whenever he saw the one ball moving towards the other, he would always conclude without hesitation that the second would acquire motion. His understanding would anticipate his sight and form a conclusion suitable to his past experience. It follows, then, that all reasonings concerning cause and effect are founded on experience, and that all reasonings from experience are founded on the supposition that the course of nature will continue uniformly the same. We conclude that like causes in like circumstances will always produce like effects. It may now be worthwhile to consider what determines us to form a conclusion of such infinite consequence. 'Tis evident that Adam, with all his science, would never have been able to demonstrate that all the course of nature must continue uniformly the same, and that the future must be conformable to the past. What is possible can never be demonstrated to be false, and 'tis possible the course of nature may change, since we can conceive such a change. Nay, I will go farther and assert that he could not so much as prove by any probable arguments that the future must be conformable to the past. All probable arguments are built upon the supposition that there is this conformity betwixt the future and the past, and therefore it can never prove it. This conformity is a matter of fact, and if it must be proved, will admit of no proof but from experience. But our experience in the past can be a proof for nothing for the future, but upon a supposition that there is a resemblance betwixt them. This, therefore, is a point which can admit of no proof at all, and which we take for granted without any proof. Unquote. All right, so unpack some of that. So, notice one thing he's saying is that his imagination comes first, which is invalid. I reject that. Experience comes first, as Newton and Galileo and Aristotle and Aquinas knew, and E. Bright Wilson probably sounds that way. So notice part of what's happening. If people don't know this, they think induction's only probable, and they have this silly example with geese and white swans and black swans, but that's not a valid induction because that's based on color. You're not looking at causation. So they're all white, like they can't be a black. Prove it, It's not a matter of imagination. It's a matter of causes in the world. You got to look at the identity of the thing and prove there has to be something requiring it to be white to have a good all statement. Just like, we know all redheads are hot-tempered, all people of whatever race are subhuman. Those are invalid inductions. They are not based on causality. They deny a lot of facts. They contradict many things. They contradict a lot of necessity in the world that is actually out there. Same thing with the white swan thing. It's silly. It's not against induction. That's against enumeration. Enumeration and induction are not the same thing. Enumeration is not a form of induction. That's just saying, oh, there's 5, so this, this 5 is like that, so others are. That does not involve causality or the identity of something. That's purely numerical. That is not induction. Induction is related to deduction. It's related to concept formation, classification, similarity, difference, and so on and so forth. Aspects of thinking and reasoning. Enumeration is not. It's just this and this and this. Oh, therefore all. Okay, well, no, there's no why. There's no looking at the nature of the thing. It's identity. It's classification, the similarities, differences, the characteristics, the attributes, the actions, the cause-effect relationships. It is not an induction. Okay? And that's a mistake he's kind of making here too, if you heard that. Hume is. But, okay, so first, again, it's what are the facts? It's not what you imagine. I don't care about what Hume or anyone can imagine. I care about what is real. So, like it says here, where is that? Okay. This is important. This is where, again, as I said, where some of this is coming from, where the idea that induction is merely probable is coming from. It's fantasy. He says, of which there is evident proof. The mind can always conceive any effect to follow from any cause, and indeed any event to follow upon in another. Whatever we conceive is possible, at least in a metaphysical sense. But wherever a demonstration takes place, the contrary is impossible and implies a contradiction. Nonsense, ludicrous. I 100% totally disagree. So would Newton. Newton said, okay, now remember, he's saying, whatever we conceive is possible. Hume says. Newton says, an induction is true, notwithstanding any contrary hypothesis that may be imagined. He's rejecting Hume, as we should all do. Look at what Newton did versus what Hume did, as I say. Newton made all kinds of generalizations, narrow and vast in scope, detailed and broad. Hume, nothing. A lot of invalid inductions. There's one right there. That is invalid. I reject. Whatever we, like, all things we can imagine are true, are possible. In a metaphysical sense, no. Invalid. Imagination is not metaphysics. It is obviously that, not that way. If we look at what he's saying and think about it, it's obviously invalid. Metaphysics, it's what's given, not what we imagine. Metaphysics comes from identifying the fundamental aspects of the world. And that's philosophical metaphysics, not like metaphysics in a bookstore, it's about witches and stuff. This is a different sense. Metaphysics is a technical philosophic term. It's a branch of philosophy. Metaphysics, what's the nature of the world we live in? Epistemology, how do we know? Epistemology is about what is science, what's the scientific method, how do we form concepts, how do we generalize, what's deduction, how is concept formation related to induction, how is concept formation related to deduction, how is classification related to induction, how is classification related to concept formation, and so on and so forth. Or in epistemology, what comes first? Quote unquote pure reason or experience. And then also in philosophy, you got morality, ethics, politics, aesthetics, the nature of art. But this is invalid. What we make up in the mind, what we imagine, is not possible metaphysically. When we do science, we reject things made up without evidence. The possible is not whatever we make up in the mind. The scientifically possible and the really possible is what we have evidence for in experience and perception. There has to be some evidence of the senses for something. Like, it could be possible that the sun goes around the earth because there's some, like, visual, there's some, like, evidence of it. But then when you dig into more things, you see it's not the case. You see in experience that, sometimes I'm moving, and if I can make it seem like the other thing is moving and I'm sitting still. Or sometimes two things are both moving, and if I'm on a ship, I don't feel necessarily myself moving, but I am. And it looks like if I'm thinking I'm still, other things are moving when it's me. Or, oh, look, we're on two ships and we're both moving, but it seems like, oh, only they're moving. We see that in experience. That is not something made up in the mind, going beyond experience. That is identifying things in an experience and putting movement in that context and saying, we got to figure out what the Earth and Sun are doing. Which situation is it? How do we classify it properly? And so on and so forth. So it's from experience. It's not some pure imagination thing. Okay, so here's a few ideas where, as I say, Hume is wrong. We should reject this stuff as Newton did. Okay, so that's one major flaw of his argument. We should dig into this philosophically and see, what is he saying? What's the meaning? What's the logic and cause-effect relationships going on here? And here he says, wherever a demonstration takes place, the contrary is impossible and implies a contradiction. So it seems like, I'll have to dig into this. This is one thing I'm not sure about. But it seems like he thinks demonstration is in the mind, not in the world. But notice that Galileo and Newton would demonstrate things in experience. It was not in quote-unquote pure reason. It was in experience where a real demonstration takes place. And I think that's what a lot of people realize nowadays. When you demonstrate something, you look at the evidence of the senses to do it. You don't turn away from that and say, we can't be sure. Like Plato said, the evidence of the senses is full of illusions and lies and distortions. So we need to go to quote-unquote pure reason to figure it out. No one does that. They know demonstration is valid and legitimate. And the evidence of the senses is a warrant for it. And as Galileo did, someone would say something like about how freefall worked, and he would show in experience it does not happen. You drop something, and things don't move at a velocity according to their weight. They fall, as he found out, according to the square of their time, and their weight doesn't matter. And you didn't say, oh, well, that's only experience. Whatever. We can demonstrate that the weight affects velocity in our mind, so it's true. Experience is just lying to us. It's full of illusions. Experience is contradicting our thought. No one thinks that. That's crazy, People nowadays know that's not the case. You see, you're thinking a certain thing, and this is what happens in reality. We see it by experience. You're contradicting the evidence of the senses. You're wrong. So the demonstration is not in our minds, divorced from experience. It's in experience, and we got to identify it. As Galileo said, all human reasoning must be placed second to direct experience. Okay. So demonstration and necessity, again, it shows necessity is not only in our mind as Hume thought, and only quote-unquote contingency and probability is an experience, it's a bunch of nonsense. Necessity and demonstration and all that is inexperience, first and foremost. What something is necessitates certain actions and necessitates certain conclusions about it. That's where the necessity comes from, in experience, not from stuff in our head. There's more contingency and probability and error in our minds than in reality. The error is not in experience or in the world. It is in some of our thinking. Some of our thinking, as you can look at everyday life, look at people around you, look what you do, look at your experience, is in our thinking where there's a lot of contingency and mistakes and error and probability. It's not in reality. Okay, so there's unpacking some of that stuff a little bit. So Hume is wrong to say whatever we conceive is possible. And again, that's part of his argument. It's an important part of saying induction is only probable. It's nonsense. Okay, he says the mind can always conceive any effect to follow from any cause. I don't care. Just like Newton said, I don't care about your ramblings or imaginings or make-believe stories or whatever. That's not what reality says. In experience, we don't have any effect following from any cause. We don't have any event following upon another. It's like, this is ludicrous. This should be laughed at. It's such an invalid argument. Okay. Now, another thing he says is the uniformity thing, like time and uniformity. It follows then, so quote, it follows then that all reasonings concerning cause and effect are founded on experience, and that all reasonings from experience are founded on the suppositions that the course of nature will continue uniformly the same. We conclude that like causes in like circumstances will always produce like effects. It may now be worthwhile to consider what determines us to form a conclusion of such infinite consequence. 'Tis evident that Adam, with all his science, would never have been able to demonstrate that the course of nature must continue uniformly the same, and that the future must be conformable to the past. Unquote. Okay. And again, that's nonsensical. He's sneaking in something and confusing people with bad epistemology. So, here, okay, uniformity means things are the same in appearance. So basically it amounts to identity. He's saying, and as you could say, we can imagine any effect to follow from any cause. That contradicts causality. That contradicts the identity of things. That's saying that a thing is not what it is. There is no warrant, he says, for something to be what it is. We can't say things always interact in a certain way because of their natures, or a thing always is what it is. That's what he means by uniformity. He's attacking identity. He's attacking the nature of things. A child is not a child. A billiard ball is not a billiard ball. This cat is not this cat. This blade of grass is not this blade of grass. We don't know it. There's no uniformity. It doesn't really have identity. That's what he's saying, and that's invalid. Then, if that were the case, deduction is not deduction, induction is not induction is not induction. The word science is not the word science. The word conceive is not the word conceive. The claim that whatever we conceive is possible, at least in a metaphysical sense, or let me start again. the claim that the mind can always conceive any effect to follow from any cause, that's invalid. That does not have identity. That is not what it is. You can't say that, you can't write that and think it's going to be true tomorrow. Remember, take it seriously. If that's what he says, that's what he's stuck to. If that's what someone wants to believe, they are stuck with that. They are stuck with their principles. If you make your bed, you're going to lie in it, as people say. So there is no uniformity to that statement. You can't say it's going to be that case tomorrow. You can't say imagination is what it is. And if we don't have cause-effect, if it's only a custom, then how can you claim imagination can do this? The mind and imagination have a certain nature and can do something, and he's implying that this is always the case. No, you cannot have that, David Hume, if you reject this stuff. If you say, in these certain cases, that's all we know, we can't extend it into the future, we're assuming a future principle and a uniformity principle, well, so are you, and that shows that this stuff is axiomatic, and you're contradicting yourself. And this is nonsensical and a bunch of babble. So, some important things here, as I say, where he's trying to sneak in ideas that violate and contradict axioms and the identity of things and their cause-effect relationships and their natures. He's saying, the future must be conformable to the past. We don't know it. We can't prove it. Or there's a uniformity of nature. We don't know it. We can't prove it, but it's nonsensical. Again, to say there's no uniformity and we don't know it is to say things don't have identity. That's what he means. But things do. Otherwise, you can't even talk about something. Words have to be what they are. Thoughts have to be what they are. Reason has to be what they are. You've got to, and experience has to be what it is. Knowledge is to be what it is. Communication amongst people is to be what it is. There has to be another person who is a person who can think, who is in the world, for you to talk to, for this to make sense. Those are given things as we know, as we talked about earlier, as Newton knew, as Galileo knew. Things have identity. Things interact in a certain specific way, regardless of time or place. Future or past doesn't matter. Okay, there's a uniformity. And again, if he's going to claim this uniformity thing, then it applies to him. Or he thinks deduction's valid. Well, no. If there is no uniformity, deduction doesn't matter, classification doesn't matter, definition doesn't matter, similarity and difference doesn't matter, it would all fall apart. Because if something doesn't have identity anymore, then the similarities it had with something else would be gone. And that would mean classification would be gone. That means you cannot apply deduction to something anymore. If induction isn't valid, deduction is no longer valid. Induction forms generalizations, deduction uses them. You cannot say all men are mortal, Socrates is a man, therefore Socrates is immortal. Oh, well, it's the future and things have changed, so now all men are mortal. Mary is a human. Mary is mortal. No, nope, not anymore. She's not. She's not mortal. Things changed. Different time. No uniformity. That's invalid. That's ludicrous. No, everyone knows that that's like silly. It makes zero sense. We know from experience that's not how the world works. The necessity, as I say, is inexperience, as Newton knew, as we actually know in our everyday lives. Experience is the fundamental and the warrant for things. We know that we get generalizations and concepts and similarities and differences and classifications and definitions from experience. It's a valid warrant, not imagination. And if we imagine something different from experience, we know it's silly. It doesn't matter. Imagining something doesn't mean it's metaphysically possible, as Hume said. What's metaphysically possible is what we see and experience, what we identify in the world. Okay, so the uniformity thing is silly. Self-contradictory, it would mean deduction doesn't work anymore. concepts don't work anymore. You have a concept with these things in it, based upon all this thinking and identification and similarities and differences in context and actions and attributes. Oh, there's no more uniformity, there's no more identity, the concept falls apart. But we know that's not the case. That is invalid. And okay, the future must be conformable to the past. I think that's a very vague statement. There's a fallacy there. Like, there's fallacies involving part and whole and part. Everyone's like this, therefore this particular person is like this. Or the average cost of the car is so-and-so, so therefore this part of the car must cost so-and-so. That's invalid. And that was known by Stephen Jay Gould, the great biologist. I wish I had that quote right now. But in this article, the median isn't the message, entitled something like that. I'll have to put a link. He talks about some epistemological things like that too, related to this point. The average is an abstraction. It's not a real thing. If you want to look at, so he found out he had cancer, and he knew about biology and statistics and variation, how things work. He knew it's not the average that was real. It was the variation that was real. The variation means the individual things in the world, in everyday experience, in reality and in our knowledge, our experiential knowledge from the evidence of the senses. That's real. The average is not real in that sense. It is an abstraction in the mind. And I think that's kind of similar to what Hume's doing here with future and the past. Future is like average. He's here. Future and past. He's looking at, the future must be conformable to the past, but we don't know that, Hume's saying. But notice, it's like, the whole entire future, we know for a fact from experience that things will be different. There's a lot we don't know. There's a lot of things in the world. There's a lot of interactions. Obviously, we know that from experience. That's metaphysical and basic. It's not something we prove. It's a basic identification in the world. Maybe you can argue a little bit about that. But it's a kind of fundamental thing. But just because of the future in general and as a whole could be different than the past, it does not at all follow that projectiles will no longer engage in projectile motion. Looking at the general and the particular, you cannot do that. Projectile motion is the way it is because of its identity in the cause-effect relationships. There's nothing about time or place comes into our generalization there. It's the identity that matters. And this thing will always act in this way under these cause-effect circumstances. It's the same. It's the things in their interactions matter, not the time or place. Projectile motion, friends, planets, electrons, atoms, forks, knives, apples, oranges, dogs, cats, water, and so on. These individual things interacting with others, it's always going to be in the same way. That's a specific thing. The identity of the thing stays the same. So to say, just because the future in general that we're aware of would be slightly different than the past, does not mean that applies to individual things. Totally invalid argument. It does not follow at all. Just like, on average, people who get this cancer are going to die in 6 months. It does not mean you will die in 6 months. It could be 1 month. Someone could survive longer. And Stephen Jay Gould knew that. He knew statistics. He knew concepts versus individual things. He knew about the variation around the average. And so he was like, what can I do to make sure I'm on the long end of the tail? What characteristics does that subgroup have that allow them to live longer? I don't have to be in this distribution. I can be in this sub-distribution to live longer if I enact certain causes. I look at the nature of things, cause-effect relationships. What can I do? What can I engage in to be there? So I hope that's clear. Saying the future is different than the past does not mean that this projectile will no longer be a projectile. That's an invalid thing. Just like, on average, people with this cancer are going to live only this long. Doesn't mean every particular individual is that way. That's an abstraction. You got to look at the individual and the cause-effect relationships, as I say. And then Stephen Jay Gould, he knew what to do. He ended up living a long time. He did not die of that cancer. He ended up dying of like something else, some other cancer, but it's not that one that usually takes people in 6 months or so. So this future and past thing, again, is an invalid argument. When you think about it more, you dig into it, you analyze it, it falls apart. But one thing we've got to see is that experience and the evidence of the senses are valid forms of knowledge. That's one thing he didn't do. He didn't fully get. And people who get this stuff, it's the same. I think people in the ecological approach to visual perception have some of the philosophic grounding, but I think some of them haven't thought through it and don't get that this argument against induction is invalid, or they probably haven't thought, as I wouldn't have either necessarily, of how to change the philosophy, get a better philosophy of mathematics as well. How does this idea that the evidence of the senses and experience is rich and full of information and is a valid warrant for things, how does that relate to induction? How does it relate to philosophy? How does it relate to thinking and epistemology? How does that relate to mathematics? How do you develop the idea in mathematics to have a better philosophy of math? That's some stuff that I think we need to do. But looking at the evidence of the senses is valid is one thing we need to do to get this straight. Like, the uniformity of nature, so to speak, as he calls it, cannot be demonstrated. Well, of course, it's axiomatic. What you have in the evidence of the senses is the given. All reasoning and knowledge and consciousness depends upon it. Like, it is to be with, like, things have to have identity for consciousness to work, for any knowledge whatsoever. It's axiomatic, it's basic. You don't prove it. You can't prove your axiom. That's nonsensical. It's a contradiction. That's one confusion he has here that he's trying to put over on people with different words, saying uniformly or future and past and stuff like that. If people understood induction and classification and concept formation and all this better, we wouldn't have this problem. But perception is a valid form of knowledge, as Newton, Galileo, Aristotle, and others knew. It comes first. We experience, we know for a fact, we have knowledge, as other animals do, that things are what they are. They do the same in future or past. They have an identity because of what it is, not because of the time. Time's irrelevant. Place is irrelevant. It's the thing that matters in its interactions with others. We experience that. So some of this is not, you cannot prove it. It's a given. You cannot start with chaos and things not being what they are and prove things have a certain nature. That's ludicrous. That's impossible. That's wanting what will never happen and can never be. It's logically and metaphysically impossible in every way. Cannot happen. So of course, you cannot prove your starting point. You cannot prove what you need to do to have proof. Proof, demonstration, have to have an identity. It has to be a process of a certain kind. You got to have a starting point and ending point. You got to have certain standards. You got to know things. It's got to have an identity. So you can't say there is no identity and it is not uniform, and then we want to try to prove that it has identity or it's uniform. You can't. Aristotle figured that out. That's why he was the father of logic, because he identified that all human reasoning must be placed second to direct experience. It's our standard. It's the standard of logic and knowledge. It's where conceptual knowledge comes from. Conceptual knowledge, I should say. And we see what makes it possible. A thing is what it is. Things have identity. That's a basic statement implied in what we do. And any attempt to deny it, as Aristotle identified, results in a contradiction of it. And that's what happens here in a lot of Hume. The future and past thing, the uniformity thing, he's contradicting himself. You cannot prove your axioms because all proof requires the axioms in the first place. All thinking. Things have to have identity, as I've said. A cat has to be a cat. A tree has to be a tree. A mouse has to be a mouse. A steak is to be a steak. Nutrition is to be nutrition. Otherwise, you can't think, and things wouldn't be what they are. That's the nature of the world we live in. So this, again, uniformity stuff, irrelevant. It's a non-argument. You cannot prove your axioms. They're the starting point for all proof. The future and past stuff is nonsensical. It doesn't matter. I don't care about future and past. I care about the identity of things. And as I say, we need to realize our inductions are valid and stop this unnecessary worrying that comes from Hume. Be like Galileo. All human reasoning must be placed second to direct experience. Be like Newton. We are to look upon propositions inferred by general induction from phenomena as accurately or very nearly true, notwithstanding any contrary hypothesis that may be imagined, till such time as other phenomena occur, by which they may either be made more accurate or liable to exceptions. It's valid. It's okay. We can form inductions. We do. We just got to know what's the logic of them and when are we correct. Rules of concepts, rules of induction, just as we have rules of deduction. And then one thing that helps with some of this is if someone makes some claims, they claim some principles, apply it to what they're saying and see if it's contradictory and if they destroy themselves. And that's what happens when we look at what Hume said. So we can go out there and be certain that things work. Again, like E. Bright Wilson said, get out into the sunlight again and know that what they say, what Hume says, is not so. Scientific principles work. Bridges stay up. Eclipses occur on schedule. Atomic bombs go off. Induction works. Concept formation works. We can think. Reason is valid. And then we can just start to think about what is induction? What is deduction? What's classification? What's concept formation? How are they related? How do I do this thing right that I know can be done right? And then we're okay. And let's stop with this silly thing that comes from Hume, with this bad argument, a lot of fallacies, and so on. But please get out there and generalize. Be a good generalizer. Be a good concept former. Be a good thinker. And enjoy life and love it. Make the most of it. And be confident that you can do it well. Hope that helps. If you have any questions, let me know. Thank you. Y'all have a good day.